Imagine with me that you're back in school and that you're faced with the world's hardest exam. It has thousands of questions, and they're all making reference to one another to create a huge web of questions. And to make it even harder, imagine that there are multiple valid answers to all the questions and that you have to find all of them. That sounds pretty difficult, right? Well, what if I told you that there are many problems in science which are almost exactly like that? I'll give you an example, which I'll take from astrophysics. The problem is to learn how matter is distributed inside galaxies. It helps us learn how galaxies form and what they're made of. To do so, we produce images like this one up top, which shows how matter is located inside a galaxy. So here, the brighter pixels indicate more matter, and the darker pixels indicate less matter. But here's the thing. When making this image, coloring one pixel is like answering one question in that exam from earlier. And just like the exam, this image has thousands of pixels. And again, just like the exam, given the experimental data we have, there are many valid images, many valid answers if you prefer. And we have to consider all of them. So here, all these other images are some of those other valid answers. Now, this family of problems has a name. It's called high-dimensional inference because there's a high number of things, pixels in this case, to infer. My research is to create the algorithms, the tools that allow us to solve this family of problems. So I'm giving you an example from astrophysics here, but it's about much more than that. It's also about more earthly things, like climate science, medical science, and more. So, how do my algorithms work? How did I generate these images? Well, I'm using generative models, similar to those that are in ChatGPT. These act as like a super pencil that lets you very quickly write down rough answers to all of the exam's questions. I combine these generative models with another completely different class of machine learning models. They're tasked with overseeing the generative process and correcting inaccuracies as they appear. So they're like a super calculator correcting all the work of the super pencil. And this approach works. Problems like the one I'm showing here that were previously a little bit too complex to solve are now solvable. This matters because whether you're observing distant galaxies in the sky or just making an MRI scan in a hospital, high-dimensional inference shows up over and over. We need to learn to deal with it, and only then can we use our beautiful science data to its fullest. Thanks very much.